Hi, so today we're having a look at 5.7 Trigonometry 2. The objectives for today's lesson: to work out the missing angles in a right angled triangle using trigonometry, to find angles of elevation and depression, and to solve problems using trigonometry. Prior knowledge we should have before we start them. We should be able to identify all the sides in a right angled triangle relative to the angle, so that's knowing where the hypotenuse, the adjacent and the opposite are, and that the opposite and adjacent move depending on the angle we're interested in. To be able to substitute values into a formula, to be able to find the missing lengths in a right angled triangle using trigonometric ratios. So if you haven't covered that, that was in the last lesson. Please make sure you've done that before you move on to this lesson. Things you'll need then: you need your maths book or some paper, you'll need a pen or a pencil to write with, and you will need a scientific calculator. Okay, so just to check our calculator functions that we're going to be using then. If you need to reset the calculator, if it's a Casio calculator, if you press Shift 9 3 equals and the AC button, it will reset the calculator to degrees. So what you're looking for is this small degrees symbol here, a little d at the top. So make sure it's showing that before you start today's work. Okay, you'll also need your fraction button. So again, just check you know where your fraction button is. If you have a different type of calculator, you may have a fraction button that says something like ABC on it instead. So just check that you know how to use your calculator properly. You'll also need your brackets functions. So they are highlighted there. And this time we're going to be using these symbols here: the sine to the -1, cos to the -1, tan to the -1. So above our sine, cos and tan buttons, to get those yellow ones we'll be pressing the shift button first to get the yellow functions at the top. Okay, so that's what we're going to work through today. So make sure you have all of those functions on your calculator before you start. Okay, so a quick recap then from last time. Our hypotenuse is always the longest side in a right angle triangle. It's opposite the right angle. So if we follow the right angle across, we will find our hypotenuse. Our angle, theta, okay, is here. So the opposite is opposite the angle, and adjacent means next to the angle. Remember, the opposite and adjacent will move depending on the angle. So with the angle here, adjacent is here, opposite here. If I have this angle up here, the opposite would be down here, and the adjacent is next to. Our three ratios then for trigonometry. So sine theta is equal to the opposite over the hypotenuse. We use the word so. Cosine theta is equal to the adjacent over the hypotenuse. We use the word car. And tangent theta is the opposite over the adjacent. We use the word TOA. So the way we remember these is usually with the acronym SO, CAR, TOA. Again, a recap of the trig triangles. So one way of helping us to remember whether we need to multiply or divide our values is to use these triangles that you should be quite familiar with from the last lesson, and you will have used them in science for different things as well. So SO, S-O-H, they always read left, up, down. Okay, so they always follow that pattern. Things next to each other are multiplied, above and below are divided, with the top one is over the bottom one. So O divided by S, O divided by H. Okay, so again, I will put up the different options that we could use there. If you need to, pause the video and just check through those again. You may have them in your notes from the previous lesson. Okay, so sine theta is equal to 0.5. What is the value of theta? So remember, what this means is we need to find this value theta. So they could call x, a, b. It doesn't really matter, but it means we want to find the angle. But we know the sine of the angle is 0.5. To be able to find theta, we need to get rid of sine. Now, normally when we're doing this in algebra, things that are together are multiplied, so we would divide. With sine, though, it's a ratio, it's a function, it works slightly differently. So we're going to use the inverse of sine, which is sine to the -1. So on your calculator, that's pressing Shift and then the sine button. If we do sine to the -1 of 0.5, we get 30, which tells us it's 30 degrees. So to get rid of sine from this side and get theta on its own, we do sine to the -1 of both sides, which cancels it out from this side and moves it across. So this is the inverse of sine. It's sometimes called arc sine, sine to the -1. You will hear it called different names. So for 30 degrees, the sine of 30 degrees is 0.5. If I know 0.5, the inverse sine is 30 degrees. So we can move back and forwards between those two values. The same with cos. Cos theta is 0.5. If I want the value of theta, I need to do the inverse cos of 0.5. So to get rid of cosine from this side, we do inverse cosine to both sides. It will disappear from here and we'll move across. Again, don't forget to close your brackets. And that will give you 60 degrees. And if we wanted to do the same for tangent, tan theta is equal to 1. So we would do the inverse tan of 1, which gives us theta as 45 degrees. Okay, so by doing the inverse, we can find an angle. So we'll always be using the inverse function every time we want to find an angle with any of these different values. Now you will notice it gives you the acute angle. So each time we've been given an acute angle. So that's your calculator always defaulted to give you the acute angle each time. We will come on to talk about other angles later. Okay, so our key point there then, if the lengths of the two sides of the right angle triangle are given, you can find a missing angle using the inverse trigonometric functions of sine to the -1, cos to the -1, and tan to the -1. Make sure you know where they are on your calculator. So remember, that's pressing the shift and then sine or cos or tan button. Let's have a go at using those then to find some missing angles. So our first step, as always, we need to label our triangle. So we're asked to find theta here. We've been given the hypotenuse. We know it's the hypotenuse because it's opposite the right angle. And we've been given the adjacent, and we know it's the adjacent because it's next to the angle that we have. So those are the two sides. So always remember, labeling the information we have. Don't label the third side that we're not needing, otherwise you will get confused. So we've got A and H. So from SOCAR or TOA, we've got H and we've got A. Only one of the words will contain both, and this time it's car. So there's our car triangle. Now remember, we want to find the angle. So we first have to start off by finding the cosine of the angle, and then we can find the angle. So to find the cosine, if we cover up the cosine, oops, sorry, that's coming from the wrong order. There we go. We need the adjacent over the hypotenuse. The adjacent was 5 over the hypotenuse of 8. And we want just theta now. So we're going to inverse cosine. So the inverse cosine of 5 divided by 8 is 51.3 to 1 decimal place. You will need to round these values quite often. Okay. Let's have a go through some more together then. So we're asked to find the value of x, so angle x. First step, we label our sides. So we have the hypotenuse and we have the opposites. That's O and H. O and H tell us we're going to use SO, and so we draw our SO triangle. We start off by finding the sine of the angle. To find the sine of the angle, we need to do the opposite over the hypotenuse. So sine x is 5.4 over 7.6. We want just x, so we need to do inverse sine. So the inverse sine of 5.4 divided by 7.6. Again, making sure we use the brackets properly. So we're going to put our whole calculation in the brackets this time. And we get 45.2777. So write down at least 4 decimal places before you do any rounding to help us not to make any rounding errors. And to 1 decimal place, that's 45.3 degrees. Our second one then, so let's have a look. Well, there's our right angle. So that's the hypotenuse, so we don't need that at all. It's not labelled. This one is next to our angle, so it must be our adjacent, and this one is opposite. So it must be our opposite. So that's O and A. So that's TOA. So our TOA triangle. We start off by finding the tangent of the angle, so we're going to cover up t, which means we need the opposite over the adjacent. So the tan of angle y is 5.2 over 13. We now need to do our inverse tangent so that we can get y on its own, and that will give us 21.8014, etc. to 1 decimal place, 21.8 degrees. Finally, our third one then. So in this one, we've been told we've got the adjacent and the hypotenuse there. Okay, so A and H, we're going to use car. So our car triangle, start off by finding the cosine of the angle. So to find the cosine, we need A divided by H. So be really careful. Make sure you get these two numbers the right way round this time, because they're always quite close in value. So do make sure we get them the right way round. So we're going to do 12 divided by 15. Again, we'd like x, so we're going to do inverse cos of 12 divided by 15, 36.8698, etc. to 1 decimal place is 36.9 degrees. Pause the video, write down the examples before you move on. They will give you a good guide as you work through your own questions. Okay, so 3 there for you to do. You're finding the missing angles x. You're giving your answers to 1 decimal place. So remember, we start off by finding which ratio to use. Then we're going to find the ratio of the angle and then use the inverse function to find just the angle. Pause the video, have a go now. Okay, let's have a look at the solutions for these ones then. So for the first one, we have the hypotenuse and the opposite, so that's so. So we're going to do the opposite over the hypotenuse. Okay, for that one. Our second one then, we've got the hypotenuse and the adjacent, so that's car. So our car triangle there, we'll cover up C. So A over H is 3 divided by 7. Inverse cos, we get 64.6230, 64.6 degrees. Finally then, we've got A and O, so that's TOA. So we're going to do the opposite over the adjacent. Inverse tan gives us 32.0053, etc. So 32.0 degrees. Remember, to 1 decimal place, we still need to give this value in the 1 decimal place column. So even though it's 0, it is still needed. Oh, sorry, that triangle's finally appeared over there. All right, just make sure you're happy with those answers. Okay, so let's have a look now at angles of elevation. So we've been given a worded question. So a flagpole is secured to the ground by wires. Each wire is 4 meters long. The wire is attached to the flagpole at a height of 3 meters. What is the size of the angle of elevation the wire makes with the ground? So whenever we're given these, it's a good idea to draw a sketch. So we've got our flagpole attached to the ground there by some wires. The wires are 4 meters long. So there are wires at 4 meters long. And they are attached at 3 meters high up the flagpole, so there's one each side. And we want the angle of elevation with the ground. So remember, angles of elevation are from the ground looking in an upwards direction. So I've labelled these, then we have our opposite and we have our hypotenuse. So let me just pause this a second. Okay, sorry about that. So we're using so we're going to cover up S, which gives us the opposite over the hypotenuse. So the sine of the angle that we don't know is 3 divided by 4. We want the angle, so we're going to use inverse sine of 3 divided by 4. So our angle of elevation is 48.5903, etc. And if we round that to 1 decimal place, we get 48.6 degrees. So angles of elevation from the ground upwards. The second one we're going to look at then is the angle of depression. So from the top of a vertical cliff, 65 meters high, a lifeguard can see a boat out at sea. The boat is 42 meters from the base of the cliff. What is the angle of depression of the boat from the top of the cliff? So we've got our cliff and our water there. So remember, the cliff and the water are at 90 degrees. and the top of the cliff and the side of the cliff are at 90 degrees as well. We've got our boat. We've got our cliff was 65 metres high. The boat is 42 metres from the base, and we want the angle of depression from the top of the cliff. So if we draw a line down from the top of the cliff to the boat, our angle of depression is, if we extend the cliff outwards, it's the angle that we're looking down at. Now, there are a few different ways you can go about working these out. So I could draw another straight line down to the centre of the boat, and you'll notice that I've formed a triangle here. Now, this height here must also be 65 because it's parallel to the cliff, and this one here must also be 42 because it is parallel to the water, so we could do that. We might also notice that the line we've extended and the water are parallel. So we've got a traversal line here. So the angle here between the water and the boat must equal the same as the angle of depression. Okay, they are alternate angles. Alternate angles are equal. So we could do that. We could find this angle here. So with this triangle here, knowing 65 and 42, this one here, and we know that the total must come to 90. So we could find this angle and take it away from 90. So with these problem solving questions, there is more than one way you might choose to work it out. I tend to go with knowing that the angle of depression is the same as the angle of elevation. So I'm going to work out the angle of elevation here. So using my alternate angles rule. So using that, then I have got the opposite and the adjacent sides. So O and A tells me I'm going to use TOA. So I want to find the tangent of the angle first. So I'm going to do the opposite over the adjacent. So 65 divided by 42. To get the angle on its own, I need to use the inverse of tan. And that gives me 57.1313, etc. to 1 decimal place, 57.1 degrees. So our angle of depression is the same as our angle of elevation. Depression coming from the top down, elevation from the bottom up. But it might be worth have a go at using the other methods as well to see if you can find it, and obviously you should get exactly the same answer. So our key point there then, we looked at this last lesson, but just to recap, angles of elevation from the ground up, angles of depression from the top down. Okay, so now your turn. So again, some worded questions. I would suggest drawing a sketch so you can see where the right angle triangles appear. Pause the video, have a go now. Okay, let's have a look then. So we've got a kite at a height of 11.7 meters. And the string of the kite is 14 meters long. So I've drawn a triangle here. So I've got my height at 11.7 and I've got my string from my kite 14 meters long. We want the angle of elevation. So that's from the ground up. So that's this angle here, which means I've got the opposite and the hypotenuse. So O and H tells me we're going to use SO. First, we find the sine of the angle. So doing the opposite over the hypotenuse. Then inverse sine to find the angle on its own, and our angle is 56.6902, etc. And it says give to 1 decimal place, so making sure we're careful with our 1 decimal place. The 9 means our 6 needs to round up to 56.7 degrees. Please don't forget your degrees symbol as well. We can measure things in different angles other than degrees, so making sure we put degrees in there as well. Okay, the Needles Lighthouse on the Isle of Wight stands 151 metres above sea level. The top of a ship is sighted 2 kilometres away. What is the angle of depression between the top of the lighthouse and the ship? Give your answer to the nearest degree. So we've got our lighthouse here, okay, which is 151 metres high. So 151 metres from sea level. From the top of the lighthouse, we can see a ship 2 kilometres away. Okay, so it's 2 kilometres in the distance all the way over there, and we want the angle of depression here. So we've got the opposite and the adjacent, so we're going to use TOA. So we need to do the opposite divided by the adjacent to find the tangent of the angle, to find just the angle inverse tan of that same value, and that gives us 4.3176 to the nearest degree. So it is an angle of depression of 4 degrees. Okay, well done for working through that. That's the end of the trigonometry and Pythagoras section, so the end of Unit 5. I look forward to moving on now to the next unit with you.